if we look at our textbook here, for example number 11, and I'll zoom in for us. For example 11, it says, prove that 6 is a factor of n cubed minus n for every positive integer n. And so what we're doing here is we're looking at the number. So what is n cubed minus n? So we're going to start with the number 1. 1 cubed is 1 minus 1, which gives us 0. Then if we take 2 and we say 2 cubed minus 2, 2 cubed is 8 minus 2 is 6. 3 cubed is 27 minus 3, which is 24. So what they're saying is, if I take these numbers, plug them into this equation, the final answer is always going to be divisible by 6. And they want us to prove that. So the first thing that we would do is we can verify it quantitatively by plugging it into our calculator. So I'm going to switch some things around. We're going to go back and start at 1. And then I'm going to count by ones, and then I'm going to change my function to x. We'll use x instead of n. X cubed minus x. Okay? And then we're going to hit table. Whoops, I wanted to hit table. And so we get the same data that they get there. And as you can see, is 24 divided by 6? Is that divisible by 6? Yeah. 60 is divisible by 6. 120 is divisible by 6. So how do we write this proof? How do we write this proof? So what we're going to do then is we are going to, let me get some paper here, list some information. We've looked at the table of values, and then we're going to try to make a determination as to how to write the proof. So whenever we write a proof, and you guys got to get good at writing proofs. I can't get this thing to zoom out. There it is. There it goes. It's not cooperating with me today. So what are we? Let's write down some information for this. So example number 11. What we're saying is if we let n equal 1, 2, 3. I'll put n here, and then we've got n cubed minus n. 1, 2, 3, 4, and so we get 0, which is divisible by 6, and 24, and 60, and dot, 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 dot. So what we're saying is the second column will always be divisible by 6. So how do we do that? How do we prove that? Well, whenever we want to write a proof, we start with qualitative. We look at the numbers, right? And then there's probably a pattern somewhere. So we got to try to recognize a pattern. And so what we're going to try to do is we'll try to do a proof and see what we come up with. So if I take all these numbers are divisible by 6, but it does not prove that this pattern will continue forever. So first, let's arbitrarily choose what n is. So to write this proof, we're going to say let me move my calculator out of the way here. Let n be a positive integer. In other words, we're saying 1, 2, 3, 4, all that stuff. Right? So consider n cubed minus n. Okay? Consider n cubed minus n. Well, how could we write that? We can factor an n out, right? So we're going to factor an n out, and I get n times n squared minus 1, right? Are those two equivalent statements? Do you guys agree with that? Now, what do you notice about this stuff right here? That's a special case. Does anybody know what that is? Difference of which factors to? n plus 1 times the quantity n minus 1. Now using the commutative property, I'll rearrange this and say n minus 1 times the quantity n times the quantity n plus 1. There's a reason why I did that. Okay? What do you notice about that? If I were to plug a number in, what would that tell you? Let's arbitrarily think about a number for n. Somebody pick us a number for n. 2. So if this is 2, what would this be? N minus 1 would be 1. What would n plus 1 be? 3. Okay, good. 1, 2, 3. Hey, that's weird. If I were to pick, let's pick another number for n. 8. What would n minus 1 be? 7. And what would n plus 1 be? 9. So what can you conclude by this pattern when we write it this way? Three consecutive numbers, right? So this would be a product of three consecutive numbers. Let me turn that calculator off so you guys can see my handwriting here. Okay? So that would be a product of three consecutive numbers. Well, for every set of three consecutive numbers, guess what? That's divisible by 3. Did you guys remember that rule? The product of three consecutive numbers is always divisible by 3, or it must contain a multiple by 3. Did you guys know that? Look at 1, 2, 3. Are one of those numbers divisible by 3? Yes. Look at 7, 8, 9. Are one of those divisible by 3? Because when we say a multiple of 3, we're really counting by 3's. And so if we have three consecutive numbers, one of those numbers has to be divisible by 3. Does that make sense? So the product of three consecutive numbers is a fancy way of saying divisible by 3. Now to show that it's divisible by 6, if we want to show that something's divisible by 6, the only thing we have to do is show that it's divisible by 3 and divisible by 2. So what's the next thing we have to prove? That this number is divisible by 2. So how would we prove that it's divisible by 2? Anyone? Well, here's the other thing too. We just have to show that one of these numbers is divisible by 2. So if we're counting by 3, won't we have at least one number that's divisible by 2 as well? Look at this again. 1, 2, 3. Which one's divisible by 2? One of them is. Therefore, the whole thing is divisible by 2. Look at the next set. 7, 8, 9. 8's divisible by 2. Because the multiples are 2 are counting by 2, so if I have three numbers in a row that are a product of three consecutive numbers, one of those numbers has to be divisible by 2. So not only is this divisible by 3, but it's also divisible by 2. And any number that's divisible by 3 and divisible by 2 is divisible by 6. Now this is very informal, but we've shown that. Does that make sense? Okay. Pretty cool.